This is a review of Assignment 3. So Assignment 3 was about types. Exercise 3.1 is to use decimal to represent money values in the vending machine. If we go over here to Visual Studio, we've got the supplied solution for this series of exercises. So we start with purchase price, and the biggest difference is right here. We have changed our field from being an int to being a decimal. Now notice that I didn't create a new field and make it decimal. I changed the existing field. That's important. You don't want to have two implementations inside of one class. It's okay to have multiple interfaces, but you don't want to have more than one implementation. So the int version of the constructor still exists, but notice I've added to it an obsolete attribute. Now we didn't talk about this in the lesson, so I didn't expect you to add this to your code. I'm just showing you that if you have two versions of something and you want to mark one as being older, you can use the obsolete attribute, and this is the message that comes out when you compile something using that older version of the method in this case. Now you'll notice also that the second parameter is set to false. That means that this is a warning as opposed to an error. So false means that it's okay to use this. In other words, the code will compile, but you'll get a message. If I had said true, then that means that this is not a warning, but an error, and the user would not be able to make use of this method. So that's a way to ease people away from using older versions of code without abruptly cutting off that access. All right, so now we have a decimal version of the constructor, as you see here. We have the int version of price, which is also marked as obsolete. And then, of course, we have the decimal version. So in this case, it's the obsolete version that actually requires us to do a little bit more manipulation to turn a decimal value into an int value for the people that are still using the int version of purchase price. Next is exercise 3.2, where we add a class to represent cans of soda using an enumerated type. And we see that here. Here's flavor, and flavor is nothing more than the enumeration. And then we have the supplied class can that makes use of that flavor. In particular, we have a read-only field that's set to default value of flavor.regular, and we have a constructor that takes a parameter of type flavor and assigns that to the flavor field. The big change is really about CanRack and how the introduction of the enum type changes it. So let's go to CanRack. The beginning of it is the same. Where it changes is with this additional method called add a can of. And as you see, what I've done here is I've taken the enumerated parameter flavor of can to be added, and I've converted that into a string, and now I'm simply calling add a can of that takes a flavor. So to create the new code, I'm leveraging some of the old code. So there are basically two ways that we could have handled this problem. One is what you see here. Simply have the new method as a wrapper to the old method. That's what I've done here. The other possibility was to take this algorithm and convert it for use in the flavor version of add a can of. And the reason that you don't want to do that is because then again you have one algorithm in two different places, and if you ever need to change the algorithm, or if there's an error in the algorithm, you have to make that change in two places, or you have to make that correction in two places, and it's pretty much inevitable that you'll end up introducing bugs into the system in that way, or certainly make it easier for bugs to creep into the system. So we don't want to do that. Another possibility would have been to take this algorithm and move it down into this method, converting it so that it uses the enumeration rather than the string, and then have this method be the wrapper where we take a string and convert it into an enumeration. So of those three, what I chose to do was the easiest one here, which is sort of a good guideline for you to follow as you do the exercises. If you look at an exercise and you say, well, there's two ways I could possibly do this, which one was intended? Almost always what I meant for you to do was the easier of the two. So make it easy on yourself. The other reason you might want to do it this way as opposed to moving the algorithm into the enumeration is because this code, presumably, since it's part of a working system, has already been vetted. It's already been tested. It's already been determined to be working and doing what we want it to do. So there is a case to be made that this is really the best of the possible solutions, given that we've already determined that add a can that takes the string is working correctly. In any case, you've got basically three options, and one of them you want to avoid. So we will see the same sort of behavior in the remove a can. So there's the string version, and here's the flavor version, which is essentially a wrapper for the string version, as well as empty can rack is full and is empty. And here in main, we see how that changes our code. We've got soda-rack.remove a can of, and now it takes a flavor enumeral instead of a string, which ultimately is better code because the compiler can actually help us with compile time errors, whereas with the string version, the compiler was not able to catch those errors. For exercise 3.3, class to represent coins, let's take a look at that code. So in this case, I created a field that represents the coin object as a denomination. It's one of these possibilities. The constructor simply assigns to that object whether you take a parameter or not. So this is the one that takes the parameter. This constructor takes a string, and so of course we have to make sure that that string can be converted. So we have some code here to make sure that whatever string was passed in is convertible, and if it's not convertible, then we just turn our coin into a slug. For the constructor that takes a decimal value, we have some more code that does a conversion. In this case, we've chosen to use a switch statement. If the value passed in was recognized, in other words, nickel, dime, quarter, or half dollar, then we go ahead and cast from the value, which as you see is done here. And if it's not, whatever was passed in was considered to be a slug. We have a decimal property that converts the value of the coin into the appropriate decimal. In this case, we have to divide by the value 100 to get the proper number. And the enumeral, of course, is simply just a matter of returning the coin object field. And we have overridden two strings so that we can use this in, for example, a console.writeLine by simply returning the enumeration name by calling enum.getName on that type of the coin object. And that's a review of assignment 3.